This video will walk you through some practice problems on limiting reactants. The first thing you need to do is fill in some blanks here in the top of your notes. A limiting reactant is the reactant that limits the amount of product that can be formed. Okay, so that makes sense based on what we call it. Essentially, it's the reactant or the ingredient that runs out first, right? It gets used up in the reaction, and once it's gone, the reaction stops, okay? You can't keep making something if it isn't there. So we can actually use that information to help us calculate it, okay? So we're not actually learning any new skill. We're just doing stoichiometry, just like we did previously. We're just going to compare our answers to each other, okay? So we're going to convert both reactants to the product that we're looking for, okay? Using the same stoichiometry that we've already learned. Whichever reactant produces the smallest product or the least amount of product, that's our limiting reactant, okay? And that's the amount of product that we can produce. So let's look at an example. So the first thing I need to do is I need to balance my equation. So I'm just going to kind of walk through this. So I have 1 sodium here, 1 sodium here. Check. My sodiums are good. Let's look at my chlorines. I have 2 chlorines here, only 1 chlorine here. In order to make 2, I need to put a coefficient of 2 in front. When I do that, now I also have 2 sodiums, so I need to come back over to the left side and place a 2 there. So now everything is balanced. Let me get rid of that stuff in the bottom. So now, okay, I have a problem. I'm given 2 moles of sodium, 2 moles of chlorine, and I want to know how many moles of sodium chloride can I produce? Okay, so again, I always like to circle, okay, what I'm looking for. That just kind of helps keep my eye on track of where I'm going, right? So I'm just going to take my 2 reactants, okay, and I'm going to solve them separately. I'm going to do the same thing. So let's start with 2 moles of sodium. Okay, remember I want to get to sodium to sodium chloride. I do that using my mole ratio, right? I'm looking at my coefficients. How many moles of sodium produce how many sodium chlorides? 2 moles of sodium for every 2 moles of sodium chloride. Okay, luckily this makes for pretty easy math. 2 times 2 divided by 2 is just 2. So if I start with 2 moles of sodium, it says I can make 2 moles of sodium chloride, okay? Now, let's look at my 2 moles of chlorine. So I'm just going to write it down. Now I'm trying to go from here to here. So I'm just going to compare my number of moles. Remember, if there's nothing there, it's a 1. Forgot my 2 there. So 1 for every 1 mole of chlorine, there's 2 moles of sodium chloride. Type this in my calculator. 2 times 2 times 2 divided by 1. I get 4 moles of sodium chloride. Okay, so now, remember, my limiting reactant is the one that's going to produce the smallest amount of product. Which one is the smallest? This one right here. Okay, so that means my limiting reactant is sodium, and my excess reactant is chlorine, or the other one, okay? So this is saying that I can have 2 moles of chlorine, right? That's fine. I can put that in my reaction. But my reaction is going to stop once those 2 moles of sodium are gone. Okay, because there's nothing else to react. It's all been reacted. Let's look at another one here. So first I'm going to balance my equation. So copper, I have 1 each. I'm good. Chlorine, I have 2 and 1. So I need to make that a 2. So I'm going to put a 2 right there in front. That means I have 2 lithium. Over here I only have 1 lithium. I need to put a 2 so that they equal out. Okay, so there is my balanced equation. So now let's look at the question. It says I'm given 21.5 grams copper 2 chloride, 10 grams of lithium, and I'm looking for moles of lithium chloride. Okay, so again, I'm going to kind of circle what I'm looking for. So I'm just going to start. Okay, I have grams copper chloride. Remember, I can't go from here to here until I convert to moles. So can I convert grams to moles? Yes, I can. I'm just going to look at the periodic table. Okay, and I'll kind of write this over on the side here. So copper is 63.55. Chlorine is 35.45, but I have 2 of those. Okay, so I need to type that in my calculator so I can get some type of answer. So when I add all that up, I get 134.45 grams copper chloride, right? And that is equal to 1 mole copper chloride. Notice how I'm writing out copper chloride every time. Okay. Now that I'm in moles, now I can look at my ratio, okay, and follow my arrows. So remember, I have an invisible 1 mole copper chloride for every 2 moles lithium chloride. So now I can plug in. I'm going to multiply everything on top, divide by what's on the bottom. And you're welcome to pause while you do these calculations. Okay, now I'm going to look at the next one. So it says I have 10 grams of lithium. So in order to go from grams to mole, I need to look at the periodic table. I don't have to do any calculations because I'm just looking at lithium, so I'm just going to write down what is found there. Now that I have moles of lithium, I can go over here to moles of lithium chloride. So for every 2 moles of lithium, I can make 2 moles of lithium chloride. So now again, I'm going to plug in my calculator, multiply by the top, divide by the bottom. So 10 times 2. I end up with 1.44 moles lithium chloride. Okay, so if I look here, I'm looking for the smallest amount. I can see that this is my smallest amount. Okay, and so my limiting reactant is copper chloride. My excess is lithium, right? So this is how much I can make. That is my answer. right? Just like up here, this is my answer. This is how much I can produce, okay? This is how much I can produce because this is my limiting reactant. So once it runs out, that's my answer, okay? So you kind of do all the work up front, and then you've got your answer already done, okay? All right, the very last thing is just percent yield. This is a formula that is found in your reference, on your reference page. We will do a calculation like this for a lab a little bit later. So we're going to balance an equation. So let's just start with copper, 5 here. Only have 1, so I need 5 there. Hydrogen, I have 12. Only have 2, so I need 6. Now I can look at my oxygens. 5 times 2 is 10. 6 times 1 is 6. That's 16. So I need 8 there to make 16. And I'm just going to erase all this stuff so it doesn't sit around in front of us. Okay, so it says determine the percent yield when 77 grams of carbon dioxide are formed from burning 4 moles of O2. So what this is saying is that in the lab, this is what was done. I made 77 grams of carbon dioxide. That's what I produced by burning 4 moles of oxygen, okay? So now what we're going to do is we're going to actually calculate our theoretical yield, okay? How much should I have made? And then we're going to compare it to what I actually did. So I'm just going to write down what I'm given, right? And I'm going from oxygen to carbon dioxide. So for every 8 moles of O2, there's 5 moles of CO2. So here, because my lab data is in grams, right, I want to make sure that my theoretical value is also in grams. So instead of stopping at moles, I'm going to continue on to my molar mass. Okay, I want to find grams of CO2. So I can do that by adding up. Carbon is 12.01, oxygen is 16, but there's 2 of them. So when I add those together, I get 44.01 grams. And then now I can just plug everything into my calculator, multiply across the top, divide anything that's on the bottom. That's 5. And I end up with 110 grams. Okay, so I'm going to stop there because of my significant figures. Remember, if I put a decimal, now that's saying that there's 3 significant figures. Okay, so I'm following the significant figures of what I was given right here. So this is saying I produced, or I should have been able to produce 110 grams. Well, let's look and see how we did. Okay, so percent yield, actual over theoretical, and then we're just going to multiply by 100. So my actual was 77 grams. My theoretical was 110. And then I'm going to multiply by 100. So I got a 70% yield, which isn't terrible, especially if I'm working with gases. Okay, so not bad. Let's do one more. So balance equation, right? So calcium, 1 and 1. Oxygen, this 2, remember, applies to everything in there. So I have 2, and then I have 1, 2. Perfect. 2 hydrogens, 2 hydrogens. So everything in this one is already nice and balanced, okay, with our invisible ones. So percent yield, okay, this is saying 47 grams is produced. So again, I want to circle what's produced so I know what I'm looking for. And I'm beginning with 39.27 calcium oxide. Okay, if you could just get in the habit, circle what's produced, underline what you're starting with, it will make setting up your equation so much easier. Okay, just come up with a trend or a pattern or something so that you can pick out all these numbers. Okay, so I'm starting with 39.27 grams of calcium oxide. Can I go from here to here in grams? No. So I have to convert to moles first. And I do that by the periodic table. So calcium is 40.08. And then oxygen is 16. So 56.08 grams. Okay, now I can keep going. Now I have moles. I can go from here to here. So 1 mole calcium oxide for every 1 mole of calcium hydroxide. And remember, my lab data is in grams. I have to keep going. I have to convert into grams. How can I go from moles to grams? Periodic table, molar mass. So let me do that down here. Put a line there. So calcium, 40.08. Oxygen, there's 2 of them. 32. Hydrogens, there's 2 of them. So I can add those up. And I'm pretty sure it's 74, but we're going to use the calculator just so I don't do something wrong on the video. 74.1 grams. Okay, so that's my molar mass. Plug everything in the calculator. Multiply everything on the top. Divide by everything on the bottom. So we end up with 51.9. Oh no, I can go one more sig fig. 51.89 grams. Okay, so this is my theoretical. So for my formula, remember my actual, this is what it said I produced, is produced. Okay, so that's my actual. So I'm going to take 47, divide by the 51.89. Don't forget to multiply by 100, because percents are always in 100. And we end up with a 90.6%. Okay, which is really good actually. Okay. So at the bottom of this, you have a little review activity. Check out the next video.